Important notice. Please read this disclaimer for safety, legal, and responsibility information. In this project, we will set up a Rust development environment on Linux for the Waveshare RP2040-Zero. This is a small but meaningful first step into embedded development. When we make its tiny LED blink, we open the door to future projects. Those projects can build creativity, confidence, and practical skills. On the product page, there is a section about the onboard RGB LED. It is a small, surface-mounted LED that can display many colors by combining red, green, and blue light. With software control, we can create different colors and simple effects. It helps us learn how code controls real hardware behavior. For more details, read the RP2040 product page and its wiki. You can also review the official RP2040 microcontroller documentation. I will open a few relevant links for your reference. You may pause this video and check them out on your browser. The RP2040 is available for purchase at Waveshare's online store, eBay, and Amazon. When shopping for this product, please make sure that the product has flash memory on board. The flash memory is where we will store our compiled Rust programs. Typically, the product listing will mention with flash or with onboard flash. The flash memory is different from the RAM, which is used by the running program. Once we set up our development environment, we will be running a demo program that is part of the RP2040 Rust hardware abstraction layer codebase. The sample program will make the onboard RGB LED blink in a simple pattern. I have opened the website link for the RP2040 Rust HAL. Scrolling down a little bit, we see the View Demos link. Click on the link and in the Go to File box, type Waveshare Rainbow to find the demo program. Once you open the file, scroll down the code a little bit and you will see the function that controls the LED blinking pattern. The dev environment will be set up as a Docker container. Let us start off by making sure we have Docker and Git installed on our computer. If you don't have them, please install them first before proceeding. The Docker file is available in our GitHub repo. There is also a README file with instructions on how to build and run the Docker image. The repo is evolving and its contents may not match what you see in the video. Please spend some time reading the README file to understand the setup process. I will now clone the repo and build the Docker image locally on my computer. I will now run the Docker container and show you how to use it for Rust development. It is important that the project directory on your local computer is mounted to the Docker container and it has the correct permissions. Otherwise, the code files inside the container will not be able to access the mounted directory, and you will not be able to build the Rust code. By volume mounting the project directory, you can edit the code files on your local computer using your preferred code editor, and the changes will be reflected inside the Docker container where you will be compiling and linking the code. Now that we have the Docker container running, let's clone the RP2040 Rest HAL boards repository. I will now navigate to the GitHub repo of RP2040 HAL boards. This repo contains the demo code for the Waveshare RP2040-Zero you saw earlier. We will use the link from the web page to clone the repo to our local Docker build environment. To be sure that I am cloning in the Docker container, I will check for the Dockerized file. This is an optional step. After cloning the repo, this repo will become available on your local computer as well. This is because we have volume mounted the project directory to the Docker container. You can also check the cloned repo on your local computer to confirm that it is there. We will now build the demo program. The web page of the RP2040 HAL boards repo has instructions on how to build the demo code. Navigate to the Waveshare RP2040-Zero board support page and locate the build instructions. In the Docker container terminal, navigate to the base example directory and run the cargo build command with the appropriate target. The build binary file will be generated in the target directory and will show up on the host machine as well. We need to convert the compiled binaries to an UF2 file format that can be flashed to the RP2040-Zero. We will use the elf2uf2rs tool for this purpose. The elf2uf2rs tool is a Rust program that was installed in the Docker container during the Docker build. The generated UF2 file will be available in the host file system. Connect the RP2040-Zero to your computer via USB while holding down the bootsil button. This will put the device in bootloader mode and it will show up as a mass storage device on your computer. Copy the generated UF2 file to the RP2040 mass storage device to flash the compiled program to the board. After flashing, the RP2040 will automatically reboot and run the program. If everything is set up correctly, you should see the onboard RGB LED start blinking in a simple pattern. Congratulations on successfully setting up the Rust development environment and running your embedded program on the RP2040-Zero. You can open the project directory in a code editor like Visual Studio Code. After you make a change to the code files, you can build the project in the Docker container and flash the updated code to the RP2040-Zero. Do not forget to run the elf2 uf2rs command to convert the compiled binary to UF2 format before flashing. I am going to make a small change to the LED blinking pattern in the code and rebuild and flash the updated code to the RP2040-Zero. If it is already connected, disconnect the RP2040-Zero from your computer. Connect it while holding down the bootsil button to put it back into bootloader mode. Copy the UF2 file to the RP2040 mass storage device to flash the updated program to the board. Like earlier, after flashing, the RP2040 will automatically reboot and run the updated program. You should see the onboard RGB LED lit brightly. Thank you for watching this video. I hope you found it helpful and informative. If you have any questions or suggestions for future videos, please leave a comment below. Happy tinkering with the RP2040-Zero.